The next buffer system that we will describe is protein buffer system. Proteins buffer system. First of all, some words about proteins and their properties. Proteins are composed from amino acids. Proteins are composed from amino acids. Amino acids are amphiolate. They can add proton due to amino group presence. They can add proton due to amino group presence and give away proton due to carboxyl group presence and can give away protons due to carboxyl group presence. That's why proteins are amphiolate too. That's why proteins are ampholates too. Proteins differ in amount of amino and carboxyl group. That's why they can divide it into neutral, basic, and acidic. But in general, they are ampholates and they can add, so give away protons. They can add, so give away proton. They will add protons or be acceptor for proton due to amino group presence. And they will donor for proton or acids due to carboxyl group presence. When protein will dissolve in water, bipolar molecule forms. And functional group when protein will dissolve in water, bipolar molecule will form. And functional group will change in their rule. Functional group will change in their group. So amino group that adding proton becomes donor, and carboxyl group that loses their proton becomes acceptor. The next sentence. Protein's buffer system acts at different medium. It's universal buffer system. Protein buffer system acts in different medium. It is universal buffer system. It is universal buffer system. In acidic medium, some amount of bipolar molecule transform into cation. In acidic medium, some part of bipolar molecule transforms into cation and becomes donor. Another part becomes acceptor. So the composition of protein buffer system in acidic medium is represented on slide. So some part of bipolar molecule transform into cation, they add protons and becomes donor. Another part stay as bipolar molecule and becomes acceptor. Mechanism of action may be represented by the following equation. When excessive of proton is appeared in biological liquid, they will neutralized by acceptor for proton. And as a result, weak electrolyte form again. If excessive of hydroxide ions will appear in medium, they will neutralized by donor for proton. And as a result, water will form. Mechanism of buffer action is represented in ionic equation. PRT mean protein. In basic medium, some amount of bipolar molecule lose loses proton and transforms into acceptor for proton. In basic medium, some amount of bipolar molecule loses protons and transforms into acceptor for proton. Bipolar molecule becomes donor for proton. Bipolar molecule becomes donor for proton. I'm sorry. I push in wrong clavish. So at slide we see bipolar molecule that is donor for proton and bipolar molecule that lose proton and transforms into acceptor. This particle can only add proton. Mechanism of action is represented on slide. So if excessive of protons will appear, it will neutralized by particle acceptor, that is acceptor for proton. And as a result, weak electrolyte will form. Proton adds not to carboxyl group but to amino group. It happens because chemical bond, polarity of chemical bond between hydrogen and nitrogen lower compared to oxygen and hydrogen. So if hydrogen will add to oxygen, this bond will breaks very quick and protons will appear in medium again. But when hydrogen will add to nitrogen, this bond will breaks heavier, and as a result, protons will join stronger. So when excessive of hydroxide ion will appear in medium, as a result, water will form. So as you see, in any case, weak electrolytes forms. It may be water or it may be another component from buffer system. So another example of protein buffer system is hemoglobin buffer system. Hemoglobin buffer system. So hemoglobin is complex protein that play different role in blood. The general rule is transport oxygen and carbon dioxide. So hemoglobin transport oxygen from lung to tissue and will transport carbon dioxide in opposite way from tissue to lungs. According to composition, hemoglobin is acidic protein. That's why hemoglobin is acidic protein. That's why we can correspond hemoglobin buffer system to acidic buffer system. We can correspond hemoglobin into acidic buffer system. Hemoglobin can form different types. Hemoglobin can form different types. Oxyhemoglobin that is joined with oxygen. Oxyhemoglobin is joined with oxygen. Carboxyl hemoglobin is joined with carbon dioxide 4. That's why composition of hemoglobin can be represented by different expression. So in arterial blood, it represented by oxyhemoglobin. And in venous blood, it's represented by hemoglobin. Of course, we know that hemoglobin at venous blood transport carboxyl hemoglobin. But this expression is more comfortable for understanding. Another component is anion from oxyhemoglobin and hemoglobin that contains potassium as positively charged particle. So I remind you that inside cell concentration of potassium is higher compared to outside cell. So inside cell concentration of potassium is higher compared to outside. That's why when we describe composition for hemoglobin as for red blood cell, we must sign potassium. So let's describe mechanism action of arterial blood hemoglobin buffer system, and I think it will be easy for you to describe venous blood system action. So oxyhemoglobin buffer system as acidic buffer system is represented by hemoglobin and potassium salt of oxyhemoglobin. Oxyhemoglobin plays donor role, and potassium salt is acceptor for protons. So when excessive of protons will appear in blood, they will neutralized by acceptor component. It may be represented by the following molecular and ionic equations. And when excessive of hydroxide ion will appear in blood, it will neutralized by particle that is donor for protons. It may be expressed by the following molecular and ionic equations. So blood as buffer system keeps the hydroxide index value at measure 7.36. Blood as buffer solution keeps the hydroxide index value at measure 7.36. Due to much organic and inorganic acids formed during metabolism, due to much amount of organic and inorganic acids formed during metabolism, amount of acceptor for proton in blood buffer system is higher compared to donors. Due to much organic and inorganic acids formed during metabolism, amount of acceptor for protons in blood buffer system is higher compared to donors. Summary amount for all acceptor for proton in blood calls alkaline reserve. Summary amount of acceptor for proton, for all acceptor for proton in blood, calls alkaline reserve. It represents by all acceptor from all buffer system. So there is acceptor for proton from hydrocarbonate buffer system. The second is acceptor for proton from hydrophosphate buffer system, from hydrophosphate buffer system of plasma and erythrocytes. The third and the fourth components are acceptor for protons from hemoglobin buffer system, from venous blood and arterial blood. And the last two are acceptor for protons from alkaline protein buffer system and acidic buffer system. So, do you have any questions to me? If you have some questions, you may write to me at the chat or at chapter questions. No, chapter questions is at right high angle questions. So this lecture will upload on educational site only as presentation. So if you need do you need in audio? So buffer capacity for blood or erythrocyte can be in excessive amount. It may be happens only during pathological process, and it will only during short period of time. So, and if excessive of proton or hydroxide ions becomes to appear, so it can lead to change in pH of blood. That's why when pH of blood increases, it is alkalosis, and when pH of blood decreases, it is acidosis. So material for prepare for the lesson is uploaded on educational site at the chapter that is called theoretical material for prepare for the lesson. Yes, you may buy books. Yes, you may buy books by author Gazinsky, Janis Gazinsky, Medical, General, and Bioorganic Chemistry. So the general books of our discipline is Janis Gazinski, Medical, Bioorganic, and Biochemistry. Biological chemistry, I'm sorry. Do you have any question else? So, okay, today in the evening I find link for this book and I upload on educational site. How does it call and what is offer? Any question else? Best wishes. You are welcome. Best wishes. So now about class. So your teacher is Professor Svetlana Potechina, and you must ask her. So if you need video file, okay, I will upload, and it will you can upload it during 2 or 3 days. So don't forget that our lecture will online because the most amount of students are outside from our Russia Federation borders. So today you must do task about chemical thermodynamic, tasks for the lesson 2 and 3. They upload on educational site. So your work, okay, thank you for the questions. So at first you must do your task at your notebooks, then you must do different photo or PDF, and you must upload on educational site. Then teacher checks your works, and they grade your works as done or not done. Deadline for all tasks is Saturday. Deadlines for all tasks are signed at educational site. If you can't find it, so you must came into educational site, then you must find chapter general and bioorganic chemistry, and there you can find all that you need. So do you have any question else? Best wishes. So I'm very glad that today is more students that at previous lecture. Don't forget that our next lecture will take place at next Tuesday. So are more comfortable to you to begin lecture at 8:30? Okay, okay. So if our lecture will begin early, I will write it on educational site. So be attentive and read information on educational site. So thank you for everyone. Wish you good day.